Hello students, in last video we have done the LED, that is the use of PN junction as an LED. Today we will do the PN junction as an photodiode. This is the photodiode, second application. So before going that, let's just look at the right hand side here. So this is the recapitulation, but very important one. We know this is the P-type crystal, this is N-type crystal. In P-type crystal we create one holes, and in N-type crystal adding the pentavalent atom we make one electron star. This is the free electrons. So remember one thing, what I am recapitulating once more, because these holes which is created in P-type crystal, it is in the valence shell only. That means we can make the picture this type. Holes are here in the valence band only and conduction band is totally free. But what happens in case of N-type semiconductor? In N-type semiconductor, as we create one extra electron, 4 electron of arsenic, they will make the covalent bonding, 1 electron will be extra. These extra electrons should stay in the conduction band. So this is the basic difference of P-type and N-type. P-type, there is an opportunity to collect the electron by the holes, but it is in the valence shell only. So they are in the valence band. But in case of N-type, electron is extra, that should come in the conduction band. And when we add these two in case of LED, last video we discussed P and N-type, automatically these free electrons are in conduction band and holes are in valence band. And we have seen in LED, these electron jumps down to occupy the space of the holes, and then only we get the light energy. Okay, so this is the recapitulation. Once more we need this one. Now come to the point, the photodiode. Photodiode, remember photodiode is the PN junction diode, but it is covered with connected in a reverse bias connection. LED was connected in forward bias, but the photodiode is connected in the reverse bias condition. Okay, so this is the picture of a PN junction diode. There is no battery connection, so we know the depletion layer and everything. In short, I am telling the N-type electron, and here is the holes in P-type. So what we will do, these N-type electron will occupy the space. That means from conduction band they are coming to the occupy the space of the valence band, the holes. Okay. So when they will go there, so automatically electrons vanish. These electrons will occupy the space of these holes, and in this way, one by one, all the electron of the neighboring this bordered area, they will occupy the space of the holes, and automatically there will be no electrons. These electrons will vanish, and whenever they combine with the holes, then the octet completed. That means it is again just like silicon atom. So in this way, the electrons of this side, when they try to come this side and occupy the space of the holes, according to this position, this free electron of conduction band, it is going to occupy the space of the valence shell only, this positive one. So when they occupy this one, they make one octet completed silicon atom. So when they make the octet completed, there is no free electron concept, no holes concept. That means we can write within this region, due to this recombination of the electrons and holes, there will be no free charges, only silicon atom. There will be no free charges in this region 1. So in this mid region, in the both side, we cannot get any free electron, but due to the recombination of holes and electrons. Okay. But one point, as the electrons are going from this side, automatically positive potential will be created. And as the electrons are coming to this region, so one negative potential will be created. We know this is called the barrier potential. We know this name. This is called the barrier potential. Okay. And we know in case of silicon crystal, this is nearly equal to 0.7 volt like this. So this is the combination before connecting the battery. Okay. Now we'll do the photodiode. So what we'll do, we'll connect in reverse bias. Let us connect in reverse bias, P with negative and N with positive. This is the reverse, the opposite one. P positive with negative and N negative with positive. This is the reverse bias condition. If we connect in this way, suppose the battery voltage in my example is 3 volt like this. So due to this voltage, what will happen? Now these negative pole will supply electron to occupy the space of the holes, and these positive, so they will bring out the electrons. So these electrons will try to go away towards the battery pole direction. They will come like this. This is the electron flow direction, not the current direction. So electron from battery will occupy the space of the holes. So those the holes were there, they will be occupied by the electrons of the battery. In this way, they will occupy this one, and automatically what will happen, then these electrons are coming back, so automatically here the positive potential holes will be created. When the electron will go away, there will be holes. In this way, holes will be created, and these battery negative electron, they will occupy the space of the holes nearby area. They will make the negative potential. In this way, you see what will happen. In this positive potential was here, now again we get another positive potential. That means we can say that the depletion layer region, the volume will increase. Now the volume will increase. That means the depletion layer will be more. Now it was the depletion layer. Now it becomes more in reverse bias. So you know in reverse bias depletion region increases in size. This is the reason why it increases. Okay. Now the point is that when it increases, automatically barrier potential will increase. Gradually, if we add one resistance, we change the voltage gradually, and ultimately reaches to the 3 volt. Then this barrier potential will gradually increase. Once this barrier potential is, suppose it comes to 3 volt, then what will happen? We are increasing in this way. Then we can think this is negative potential, this is positive potential, increases the depletion layer. So when these two voltages are equal, we can make one equivalent circuit like this. That was for this barrier potential, and this is for the battery. This is the original battery of 3 volt. So when they connect in this way, now see what will happen in this position of negative reverse bias. Both the batteries are in 3 volt. So when there is equal voltage, automatically there will be no current. So these concentration or changing over will go on until and unless the barrier potential is equal to the battery voltage. In this position, both are in the same voltage, so no current flows. So this is the case when no current flows. So this happens in normal PN junction diode also. Now what is the specialty of photodiode? In photodiode, this section is made up of transparent material. So if it is a transparent material, then if we just spray the light, that means if we follow the light from outside, if we focus the light on this section only, then what will happen? This light, that means this light is nothing but the photon particle. Photon particle will enter inside this region. But here is one silicon atom like this. Silicon atom, when they are like this, the silicon atoms are there. So when these photons will come, photon have the energy E equal to h nu. So this h nu energy photon, when it will enter here, then what it will do? That it will just extract the electron from the silicon atom. Those who are static in this first position, but due to the focusing of this photon particle, they will release the photon electron from the silicon atom. Automatically what will happen? One holes will be created here as the electrons are going away. In this way, so many silicon atoms, due to the action of this light photon particle, they will emit the valence electron one by one. So automatically what will happen? The negative polarity will increase gradually. Negative potential will increase gradually. Automatically, as the holes created, so automatically what will happen to occupy the space? From this side, they will go to occupy the space. So when they are going, the electrons are going, those electrons are came here, now they will go back. Automatically holes will be created along this side. So in this way, see, this is the action of the light particle. Because when the photon particle hits the silicon atom, then electron releases, and electron release means one holes created. To occupy the holes place, the electron from this negative side, they will go there or to occupy this. So when the electron will go, one positive layer will be created. If it continues, after some time we will see that the potential decreases now gradually. Because the holes created here, electrons created here, so this potential will decreases. That means which was 3 volt initially, we make it, now it drops down. Suppose due to the your incident of the light for photon particle, suppose this action goes on and automatically the potential barrier, which was that we set it at 3 volt, now it will decrease. Suppose it becomes 2 volt now. Due to the decrease of size of depletion layer, now it becomes 2 volt. Now battery is 3 volt, it is 2 volt. That means we can get the current. Yes, now the current will start. So this is the action of photodiode, that whenever we focus the light, then only it starts the conduction. So these instruments actually, suppose in street light also, sometimes we can, if we focus the light, sunlight comes, automatically photosensitive cell, when the light falls on it, automatically circuit starts. So how it starts? Because this is the position, we make it first, initially we make it a big, this type of depletion layer, big depletion layer, and the potential supplied 3 volt, and the barrier potential, it also set up as 3 volt. So no current was passing. But as soon as we focus the light, what will happen? We already discussed just now that the atoms will release the electron, and these electron will increase the number of electron in this section. Automatically holes will be created along this side. So the depletion layer will decrease in size. When the depletion layer will decrease in size, barrier potential will not stay at 3 volt. It should come, suppose 2 volt. So when it is 2 volt and it is 3 volt, automatically difference of 1 volt is there, automatically current passes through the circuit. So due to the passage of current, what we use the photon particle to start the action. So this is the photodiode which connected in reverse bias condition. Then whenever we focus the light on this transparent area, then only it starts the action. So it looks like this type of material. There's 2 leads are there and 1 space is there. From there it can sense the light. So this is a photosensitive cell. Whenever photo means the light falls on it, then only it starts the action. So it is used in the street light also. When the sunlight will fall on it, then the your PN junction diode which is in reverse bias, it starts its action. Automatically it will stop the circuit or something else. We can do this one. So this is the photodiode where we use the PN junction diode in the reverse bias. Okay. So this will give you idea about the photodiode. LED is over. Now this is the photodiode. Hope you will understand this one. Thank you.